Hey guys, and welcome back to another video on my YouTube channel. This video is about solving past paper questions on trigonometry. We're going to be covering concepts involving angles, the sine rule, the cosine rule, and area of non-right-angled triangles. So let's get started. We're going to be solving question 4 from paper 4, variant 2, February-March 2022. Here's question 4, part 1 of part A. It says in triangle ABC, AB equals to 45 centimeters, AC equals to 29.5 centimeters, BC equals to 35.3 centimeters, and angle CAB equals to 51.6 degrees. Calculate angle ABC. Okay, so we are dealing with two pairs of angles with their opposite sides respectively. One pair is angle CAB, 51.6 degrees, and the side opposite to it, which is 35.3 centimeters. The other pair is angle ABC, which we have to find, and the side opposite to it, 29.5 centimeters. Therefore, we can use the sine rule formula for a missing angle here to find angle ABC. So, substituting into the formula respectively, we get the sine of angle ABC over 29.5 equals to the sine of 51.6 over 35.3. Then we solve for angle ABC. Multiply both sides by 29.5. Then, take sine inverse of everything on the right side of the equation. This gives us a long value, 40.9141, and so on. Rounding that long value off to three significant figures, we get 40.9. Therefore, the answer is angle ABC equals to 40.9 degrees. Now for part 2 of part A. It says to calculate the area of triangle ABC. To answer this, we just substitute the respective values into the formula for finding the area of a non-right-angled triangle. That formula is area equals to a half into A into B into the sine of C, where C is an angle, and A and B are the sides between which the angle C is. There are two ways to solve this question. We can either substitute into the formula 29.5 centimeters and 45 centimeters, and the angle between those sides, which is angle CAB, 51.6 degrees. Or we can substitute 45 centimeters and 35.3 centimeters and the angle between them, which is angle ABC, which we found in part 1 of part A. However, I'm going to solve this question by substituting 29.5 centimeters and 45 centimeters and the angle between those sides, which is angle CAB, 51.6 degrees. So substituting the values gives area equals to a half into 45 into 29.5 into the sine of 51.6. Entering all that into the calculator, we get a long value, 520.1765, and so on. Rounding to three significant figures, we get 520. So the answer is 520 centimeters squared. Now to solve part 1 of part B. It says the diagram shows a quadrilateral PQRS formed from two triangles, PQS and QRS. Triangle PQS is isosceles, with PQ equals to PS equals to 32 centimeters and angle SPQ equals to 56 degrees. QR equals to 47 centimeters and angle SQR equals to 60 degrees. Calculate SR. As you can see, to find the length of the side SR, we can use the cosine rule formula for a missing side length, because we have and can find everything we need to substitute into the formula. So, substituting the respective values in the formula, we can see that we have to find the length of the side SQ in order to find the length of the side SR. To find the length of the side SQ, again, we can use the cosine rule formula to find a missing side length, as we have all the respective values we need. So we substitute the values respectively into the formula and get 32 squared plus 32 squared minus 2 into 32 into 32 into the cosine of 56. Then we take the square root of both sides. Entering all that into our calculator gives us a long value, 30.0461, and so on, which is our value for SQ. However, we do not need to round it off to three significant figures, as we will use this long version of the value in our calculation further. The reason for using the longer value is simply because it will give us a more accurate and correct final answer. Moving back to solving the question, now we substitute the long value of SQ into the formula to find SR. Then we take the square root of both sides. Entering all that into our calculator gives us a long value, 41.2262, and so on. Rounding off to three significant figures, we get 41.2. Therefore, SR equals to 41.2 centimeters. Now, to solve for the last part of the question, part 2 of part B. It says to calculate the shortest distance from P to SQ. Okay, so the shortest distance from P to SQ would be the distance from P that is perpendicular to SQ. I've drawn this distance as a blue line here and labeled its length as y centimeters. This blue line is from P to SQ and is perpendicular to SQ. Since the blue line and SQ are perpendicular to each other, they are at right angles to each other, as I'm showing you here. Therefore, these two new triangles here are right-angled triangles. So, as you can see here, we need to find the length y of this blue line, which is the shortest distance from P to SQ. To do that, we can use SOHCAHTOA, because we have a right-angled triangle, and we can find the angle needed, which is angle S. We can also solve for y using this right-angled triangle and angle Q. It's the same thing. However, I'm focusing on this right-angled triangle to find y. Moving back to the question, we know that triangle PQS is isosceles. In an isosceles triangle, two sides are of equal length, which over here are sides PS and PQ, which equal to 32 centimeters. The angles opposite these equal sides respectively, angle S for PQ and angle Q for PS, are also equal because the triangle symmetry ensures that the angles are mirrored. So we know that angles S and Q are equal. We can label them X, which is the value of both these angles. Now, we know that the sum of all the angles in a triangle equals to 180 degrees. This means that 56 plus angle S plus angle Q equals to 180. Substituting X in the places of angles S and Q, we get 56 plus X equals to 180. Simplifying, we get 2X, and then we subtract 56 from both sides. This gives us 2X equals to 124. Then we divide both sides by 2. This gives us X equals to 62. This means that angles S and Q equal to 62 degrees. Now, we can decide which trigonometric ratio, so CA or TOA, we need to solve for y. We know the hypotenuse is 32 centimeters, and we are solving for the side opposite to angle S, which is y. So, since we are dealing with the hypotenuse and the opposite side, we use sine of theta equals to opposite over hypotenuse. Substituting the respective values into this ratio, we get the sine of 62 equals to y over 32. Then we solve for y. Multiply both sides by 32. Entering the sine of 62 into 32 into our calculator, we get a long value, 28.2543, and so on. Rounding to 3 significant figures gives us 28.3 equals to y. Therefore, the answer is 28.3 centimeters. Thanks for watching. If you have any doubts, please comment below and I'd be happy to answer them for you. Please like and subscribe. To find more videos on solved and explained past paper questions on various topics, please view the playlist. I'll be back with another video soon.